Hello and good day everyone. We are from group 25 and we are going to present about shear force and bending moment. First of all, what's shear force? Shear force is the force in the beam acting perpendicular to its longitudinal x-axis. For design purposes, the beam's ability to resist shear force is more important than the ability to resist an axial force. Axial force is the force in the beam acting parallel to the longitudinal axis. The shear force at any point along the beam is the total forces acting perpendicular to beam longitudinal axis up to the point. Second, what is bending moment? A bending moment is a measure of the bending effect that can occur when an external force or moment is applied to a structural element. The bending moment at any point along the beam is equal to the area under the shear force diagram up to the point. For a simply supported beam, the bending moment at the ends will always be equal to 0. The importance of the test is to study the shear force and bending moment at the particular section, XX section, and compare with the theoretical calculation.
First, check the digital force display meter read 0 with no load. Next, place a hanger with a 100-gram mass to the left of the section XX. And then, record the digital force display reading in a table. This is the value of shear at the section XX. Repeat the procedure by using the masses of 200 gram, 300 gram, 400 gram, and 500 gram, and then convert the mass into load. Once again, check the digital force display meter read 0 with no load, and then carefully apply load on the beam with the hangers in the position shown in figure 2S13 using the loads listed in table 2S13. After that, calculate the support reaction RA and RB and calculate the theoretical shear force at the section XX. And then repeat the procedure with the beam loaded in figure 2S14 and 21S5. First of all, check the digital force display meter read 0 with no load. And then, place a hanger with a 100-gram mass at the section XX. After that, record the digital force display reading. And then repeat the same procedure using masses of 200 gram, 300 gram, 400 gram, and 500 gram. And then convert the mass into load. And then, once again, check the digital force display meter read 0 with no load, and then carefully apply load on the beam with the hangers in the position shown in figure 2S16 using the loads listed in table 2S15. And then calculate the support reactions, which is RA and RB, and calculate the theoretical bending moment at the section XX. And then repeat the procedure with the beam loaded as in figure 2S17 and 2S18.
For discussion, the value we get from the experimental is less than the value from the theoretical. Here are some factors that affected in both experiment and theory. 1. The way we handle the apparatus when doing the experiment. 2. The way we calculated the theoretical equation. This result can be improved so that the result will become more accurate. One of the importance of shear force in civil engineering is that we can use a shear force to analyze the beam. In conclusion, the objective of this experiment has been achieved since shear force and bending moment at x-axis has been determined for all beams.